fully expect people to keep on walking in as soon as we start. So if I wait, then somebody else will come in, and so we'll just get going. Welcome to the terminology track. Not always necessarily the most exciting track in FHIR DevDays, but actually terminology is pretty important. So something I want to do today is hopefully, I'm a bit too enthusiastic about it, which is a little bit worrying, but hopefully you'll see why and why we're here. So today I'm going to be giving an overview of SNOMED. First of all, how many of you are, well, obviously know SNOMED, but know how to use SNOMED and have experience with it? Spattering. Used it. That's good. That's good. That's the starting point. Well, now we're going to hope to explain what it is. So the point of today really is to kind of open up what SNOMED's about and try and get rid of some of the myths that we hear about. My name is Rory Davidson. I'm from SNOMED International. So it is our fault if there is issues, but hopefully we're here to answer any questions you have. The point of today is really coming at it to a group of software developers like this. I'm a software developer by background. I'm not a terminologist. I'm not a clinician. I just like playing with code. And so the reasons why we wanted to be here was to kind of explain how SNOMED fits very nicely into software development. And as we go through, you'll see the benefit of using it and why we should be and how to use it. And also really to see how do we use it easily. We have 2 sessions, this one which is the overview, and we have a hands-on afterwards. So if you do want to hang out in SNOMED, there's an hour and 20 of SNOMED. Living the dream. Okay, so a quick introduction. It's almost like a bit of a context, and everybody here will understand this. You know, we've had electronic healthcare records for really the last 30 to 40 years, and that was a great start. You know, we moved away from surgeries and hospitals that had reams and reams of documents and papers. And the first step was we put them into PDF form, and now we've electronic records. Now, that's kind of a good start, but obviously we can't really do much with it. We can't make that meaningful. How does a machine understand free text? How does a machine understand the abbreviations that a clinician puts into a notes field and a patient record in a hospital? There's a lot of these that are out there. So how do we make sure that we can use the data that we record? And so this is where SNOMED comes in. You know, SNOMED allows us to record that clinical information against patient encounters. And it's part of most EHRs today now talk about coding systems, and really what we're trying to do is almost evangelize why SNOMED fits this box and why you should be looking to use it. So big benefit of SNOMED and why we keep on saying sending this message is, you know, SNOMED's a very logical thing. This is why it's interesting talking to this audience. It actually makes a lot of sense. It's a very simple logical model. It allows us to have a common framework. It's very standards and framework oriented. It has post-coordination, which we're not going to go in today because that starts to open up a bit of complexity that we don't really have time to do in 40 minutes. But it does mean that you can extend the terminology infinitely if you wish to. There's a very strict update and versioning process. There's a full audit trail, so something that was no longer used from 10 years ago, you can still find out why and what it's been replaced by. So there's a very nice trail from machines to be able to keep track of what code you're working with. And you can see the full historical view of SNOMED back to 2002. And so this is the marketing line that you always hear. It's the biggest, most comprehensive coding system. There are 350,000 clinical codes within SNOMED CT. There's still more to add, but it covers an extremely large scope of sometimes unexpected concepts. So we're going to a bit of an introduction to SNOMED, what the components are, just to give a bit of context before we get on to the FHIR Terminology Services. So you hear about SNOMED, and people always talk about really concepts. And I think of concepts as the unit of work. So everything hangs around a concept. A concept has descriptions, and a concept has relationships. Other parts of logical design to be aware of. You can localize SNOMED. We obviously work at SNOMED International. We work with many countries, and so it's localized, it's translated. But some of the benefits you'll see is that the identifier for concept never changes. So we're really ticking the interoperability checkbox. People can extend it. You'll be well aware there's a US edition. There are other extensions in other countries from the international, and that's used for translations for local concepts, administrative concepts in the US in particular. It has a concept model that's very well defined. SNOMED is self-referential. It describes itself. It's an ontology that allows you to really find out how does the model exist. The model itself is within SNOMED. And it has an expression model, so you can express more than just a single concept. You can post-coordinate and express more than that. There's a lot of things in there, but actually today we're just going to talk on these bits and a little bit on that bit. So reference sets, which link to value sets, but really, what is a concept? How do descriptions hang together, and what are relationships? So concepts. As I said, the concepts are the central component. They're the unit of work. Every single concept has an identifier. That identifier is made up of a number of aspects. It's got a sequence, something called a namespace, which means you can tell roughly where that concept's come from. It has a type, which allows you to identify whether it's a concept or another type of component, and it has a check digit. But ultimately, it's just a number, and it's unique within SNOMED across the globe. Every concept has what is called a fully specified name. This is essentially the single unique way of clinically describing that particular concept. And these are both linked, so they're immutable. They do not change. You cannot change a fully specified name. If you change that, you need to inactivate it. And this is back to the history mechanism around SNOMED, in that nothing ever gets deleted. Everything's a logical remove, so you inactivate it, but you can still find it. And you get told what it's been replaced by. So when you see a concept with a fully specified name and identifier, that is pretty much fixed for all time. And again, that really helps the interoperability message. Descriptions. And this is one of the nice things that SNOMED does compared to some terminologies, in that you can have multiple descriptions. Every concept must have a fully specified name, as I talked about, and at least one synonym. And that synonym tends to be something called the preferred term. And the preferred term is generally based on language. So here, for example, we see appendectomy is the procedure, with a procedure, which is the FSN. It has a semantic tag. Back to, SNOMED is an ontology. It sits in the semantic technologies. And so the FSN has a semantic tag. It contains, it's a hierarchy tag, so you know that in this scenario, I always have an issue saying appendectomy is a procedure. The synonym, as I said, you can have multiple synonyms against a concept. Here we have a preferred term, which is appendectomy in the US, but we also have other ways of describing this clinical term, this clinical meaning, appendectomy and excision of appendix. These all mean the same things. So you'll see some concepts that have up to 10 or even more synonyms to basically explain what is the language used locally to explain that particular clinical meaning. And this is what we mean by a concept represents a clinical meaning. That model is the clinical meaning of that concept. But the synonyms can be multiple things.
Would you put translations here too?
Well, you jump in a gun, but yes, almost. Wait. So yes, I will get that in the next slide. Description types. There's one more description type. It's called a definition. It's not used very frequently. This is really used for, at the moment, mostly rare diseases, for references to see where these come from. But you wouldn't expect these to appear in an EHR or with your clinicians. Translations. So this is where it comes into it. So a translation in our world is just another synonym. It just happens to be in the language. So when you look down here, the benefit is you can see we have appendectomy in US, we have appendictomy because we spell it a bit different in the UK. You also have appendectomy in Danish and Swedish and also in Spanish. But the ID stays the same. So when that patient record has the identifier and you go across countries, then it always is the same. People can understand it. In the European context, where there's a lot of countries with very close borders, it's invaluable. So you can go with your record, and wherever you go, the local clinicians will be able to understand the clinical concept that's been recorded against your patient record.
But the FSN is always the same.
Yes. The FSN never changes. Generally, most languages don't translate the FSN. And this is down to an experience thing that we found when we were translating between English to French, for example, that French has a smaller vocabulary than English. And so we started to find that we didn't have unique FSNs because we couldn't translate exactly. So we defaulted to saying the FSN is a clinical meaning. And that's not what you would display to your clinicians generally. You would display their preferred term. And so here we would say the clinician will be looking to record appendectomy. So what makes sense locally, basically. Sorry? Yes, so every synonym has a language ISO code. But the way that languages work is they link to something that's called a language reference set, in that you can say, here's a description, and here's its acceptability in the language. So for example, here we would say that appendectomy is not acceptable in US English, but it is in GB English. And similarly, the Spanish version is not acceptable in any of the Englishes, but it's preferred in Spanish. So yes, it's very well defined. One thing that is a little interesting, whilst I said that FSNs are unique, yes, so there was a decision made a long time ago because SNOMED International does translate the Spanish edition. And at the time, it was decided to translate the Spanish FSN, but it's the only language that does that translation. It's very much a local country decision. So Sweden, for example, have translated the whole of SNOMED. They've only translated their preferred terms. So you can choose, but generally, so the benefit of speaking English that everybody kind of understands a little bit. So if you understand the clinical meaning, then people are happy to check the FSN in English and, quite frankly, save a bit of money to not translate them. Every word has a cost. So one thing that is interesting, as I said, synonyms actually are not unique. It's an example here is the fundus, which clinicians out there will understand this. I didn't. I won't even explain it because it's the bit opposite the opening of bits in the body. And essentially, but this actually is more than one thing. It's a synonym across multiple concepts in the body structure. Another example is cyst. Cyst can be a morphological abnormality. It can be a disorder as well. So you can have that term coming across, and this is where you use the FSN in coordination to identify, actually, okay, we're looking at different things. So on to relationships, and this is where you start to get the real power with SNOMED, and this really starts to play out when we start talking about analytics. And
sounds like a bad synonym.
well, it depends. So synonyms are made for the local environment. So if cyst is multiple things and the fundus is multiple things, yeah, I'll blame clinical vocabulary. So onto relationships. Every concept has a set of relationships. And these relationships essentially define the concept. And this is back to the machinable expression of a concept. So here we say every concept it's a type of something. Everything has one parent. But it also has relationships which we call attributes. And a simple example, carrying on with our appendectomy, is that an appendectomy is a type of procedure. Kind of makes sense. But it has a procedure site on the appendix. So from a machine point of view, it now knows that this happens on the appendix and it's a procedure. And I haven't got to describe it. It's a very simple model. But what you also have in SNOMED is, as an ontology, you can have multiple parents. So here, for example, appendectomy is an operation on appendix, but it's also a partial excision of the large intestine. These are both correct. So depending on your data and how you're slicing your data, that concept will appear in essentially the queries and analysis you can pull together. But what that starts to look like from a hierarchical point of view is here we have appendectomy, an operation on appendix, and a partial excision. They then have their own parents. They have their own parents, and then their own parents, and it basically grows to the point of the top of the tree, which is the single SNOMED CT concept. Now, the interesting thing is that anything in there is a true statement. So appendectomy is a procedure by site. Appendectomy it's a removal. These are all valid questions. And so you can see the analysis, you start to be able to come down on what you're doing with the concept. Yes?
Is this all available from the number? If I just know the number, will I be able to tell all that information?
Yes, and I will show that through, and this is where we get to in the FHIR services. You can see this information. So attribute relationships, we call them relationships, but they're just almost side relationships, attributes. Appendectomy here, for example, it has a procedure site on the appendix structure, like we just showed, but it is an excision. So we now start to see that this single concept has an attribute of appendix structure procedure site, and the method is excision. Again, I start to be able to machine this and understand what I'm looking at. And then that starts to look at the defining relationships of appendectomy here. It's an operation on the appendix, it's a partial excision of large intestine, it happens on the appendix structure, and it's an excision. Now this is a fully defined concept. All of those must be true, and you have that very specific clinical disorder that procedure that you've recorded against a patient record. And it comes back down to this machinable. There's no ambiguity in here. There's no, okay, it might be a type of appendectomy. If that code is there and it's been entered correctly by the user or the clinician, then you know very specifically that that patient has had an excision on the appendix structure as a starting point. And you can build out that information from that particular model. But the next slide is the one that I really like doing with technical audiences, in that, good old data model picture. But this is what SNOMED is. It's a very simple data structure. Everything is a SNOMED component. A concept has multiple descriptions, and a concept has multiple relationships. And that itself defines the whole model of SNOMED and how it hangs together. The other thing before we start to get into the FHIR Terminology Services is to talk through sets. You heard me mention reference sets. We have value sets, we have subsets. So it's always quite useful to say what are they and what are the differences. So reference sets is a very particular SNOMED artifact. It's essentially a set of references to SNOMED CT components. So that can be a list of, let's say, for example, allergies. It could be a general practice reference set. So these are the concepts we use in general practice. It can be a little more, it can be used for maps as well. So these are very specific SNOMED things. And I'm explaining this because you won't hear about reference sets within the context of FHIR, but we equate them between the two. So value sets is a FHIR resource. It's a uniquely identifiable set of valid concept representations. The difference being it's not just SNOMED. And that has a very useful context in many of your environments, I'm sure. Obviously, I'm coming from the SNOMED viewpoint, and we'll give you some demos on how this works in SNOMED, but value sets can be used for many different things. And then we have subsets, which people talk about as well, but these are just really the definition, the mathematical definition of a set. It's a subset of a larger set. There are no unique identifiers, likely going to be in an Excel spreadsheet, and I pass it around by email. They're not something that sits in the interoperability playing area. With SNOMED CT, the way we work with value sets and subsets is that we represent these as reference sets. And the one thing that a reference set is, and just to kind of clarify, is it's something that's published and versioned. So every reference set has a unique identifier in its own right, and it then gets published and versioned. So you'll get this out of the US edition and other editions. Now what that means are the benefits. So I put a table together to see what's the differences and where you use them. So reference sets are, where we really see them being used the most is from point of view of reporting. And the best example is national reporting. We have countries who, for example, are reporting on smoking-related diseases. So what you do is, so that you ensure that all your organizations in your country or territory are reporting the same things, you create and publish this version reference set so everybody's using the same set of codes. And people aren't just adding things when they feel like it. So your report at a national level or a regional level is standardized. Reference sets also get used for other things like maps. So we map between multiple terminologies and coding systems, and we do that in reference sets. They are an extensible structure that allows us to say, here's a source concept and here's the source code in another terminology. Value sets are a little bit more free, and that's the nature of value sets. They're useful for local users. They're useful to create them locally. They're not necessarily published or released, but they have a very different use case. And a subset's just a subset. I couldn't think of anything for that, really, but it's just a subset. So I'm going to go into the FHIR Terminology Services. Before I jump in there, I thought has anybody got any questions or questions about the SNOMED stuff that's not quite clear yet? Normally, we have lots of online e-learning courses, and they take normally about 10 hours, so I've just compressed that into 15 minutes. So there might be some bits missing, but if you have any questions, just come and speak to me or Peter, or go to Jim's talk tomorrow. There's lots more information you can get from people around. So, FHIR Terminology Services. FHIR, from my point of view as a developer, has really come at the perfect time. For my sins, I was involved in HL7 version 3 in the UK, and I tried to wash it off and move on from that. But FHIR has really started to bring healthcare IT into the world of other industries. You know, if you ever worked in finance or tourism or other areas, you know, this type of approach, REST APIs, is not new. And healthcare has always taken a bit longer to get into that world. And so it's really refreshing that now, you know, we have this community, 600 people. It just blows my mind. It's excellent that we're getting there finally. And so we really see the benefit of having terminology services to allow people to access SNOMED in a more simplistic way without the complication that people often throw at terminologies like SNOMED. So the things we're going to talk about, I was going to draw a picture, then I realized that the picture on the HL7 FHIR website was better than I could do, so I just copy and pasted it. But the things that we're really going to talk about are the code system, the concept map, and value sets. The other ones on the picture, so element definitions and elements are very much within the profiles that many people are speaking about over the next couple of days. But from a terminology point of view, we're really focusing on these three areas. And so the code system allows you to define the code system. There are particular operations that will show. Concept map is used for translation. Now, we use that from a point of view of mapping. That's how we've translated that from a SNOMED point of view. And value sets. How do we use value sets? How do we create value sets? And how do we retrieve them? So code system, we'll start with code system. Code system has a number of operations. Validate code, subsumes, and lookup. They're somewhat self-explanatory. So validate code is provide a code, validate that it exists. True or false? From a single code point of view, and this is very much a personal opinion, that, you know, do you do a lookup for a code? Do you get a validate? If you get one back, is that valid? You know, there's a different thing about that. But where we see validate code being used is when we start thinking about post-coordination. And post-coordination's expressions, validate that. Is it a valid expression? That's where that is really going to come into play. Subsumes is a relationship, a type of X. So we think back to that picture with the appendectomy up to, you know, there was a removal was one of the concepts. You know, is appendectomy subsumed by removal? I was getting the wrong way around. Then you can ask that question and find out, is it a type of, essentially. And then lookup, which is a bit more straightforward. Here's a code. What does it come back as? So as we're all developers here, obviously, we have to give some examples. And so I'll show you some examples. So here's an example of how do we look up the SNOMED CT code 427, now, that's right. I can see.
So that assumes you have imported the whole SNOMED coding system.
Correct. Yeah, and one of the things we'll talk about in the hands-on session after this one is, so one thing that SNOMED International does, while SNOMED has a licensing model at a country level, we produce a lot of open source software, so we have an open source terminology server that's fully FHIR enabled for SNOMED CT. So this is using that particular software. So, and I'll walk through that a bit in the next session. But for now, if we look at the URL here, so what are we looking at simplistically? We're going to code system, we're looking at the lookup operation. The system that we're using is this particular URI, so snomed.info SCT. You'll always see that when we're using SNOMED, that's a specific URI. The code is the code we're looking at, and the JSON. We return JSON just because it's easier to look at on a screen. But if I click this through, it should show, so I'll do that. So this is the response from that lookup. So the initial display, it's an obstetric, I really should choose ones I can say, umbilical artery Doppler, and that's the FSN. So you can see we've responded with the FSN. And that, to a certain extent, is a choice around the terminology server. Because where we see the ones that SNOMED International works with, they come in from different countries and different contexts. The FSN is very specific, so we don't have that issue around duplication. The syst, for example, we can say, this is the particular concept we're getting back. And then we start to see the designations, or essentially the descriptions coming back here. We see obstetric umbilical artery Doppler, it's a synonym. And to your question about language, EN. Now, if I go down and say, okay, here's the procedure, here's the FSN, fully specified name, again in English. It has another synonym. It's a third synonym, Doppler ultrasound scan of umbilical artery. One of the things that we're still working through with Terminology Services working group is how do we then explain which is the preferred term? There isn't currently a mechanism for that yet in the Terminology Services API, and there's complexities around languages and context as well. But that eventually, I expect that to appear at some point. Yeah.
Why do I have a different code here? I mean, is that the value? I see a code. That's not the code I started with.
No.
With the search.
So this value coding is saying that, again, it's a machinable thing. A synonym is also a concept. So the description of synonym as the reference data is that particular ID. So we're saying that this is a synonym which has that ID, as in the type has that ID, basically.
Not the same synonym you showed at the beginning. No, you had
That's a code for synonym. So this is the self-referential part of it. So, and it comes down to the reason why we provide the code is at a machine level, the machine needs to understand that this is a synonym, it knows through that it has that information.
all right. I didn't catch that.
Yep, sorry. That's good. It's a very good question. There's a lot of codes.
It's not a bundle that you can buy?
Sorry?
Not a bundle that you can buy?
No, not in the lookup. Not for a single concept. Yeah. So we have the designation, then we have properties. So we have the effective time, which is the versioning aspect. So this concept was created in 2007, July 31. It has a module ID. Now, module ID, every concept has a module ID. And that is generally linked to the organization who has created it. So this particular module ID is the international module ID. If you find a concept that's been created in the US and used in the US edition, that will have a US identifier. Where that comes into use, that's used if you are working with a system that's in multiple territories. Then you would use the module to see what you would display and not necessarily what you wouldn't. But then we have parents. So we talked about the parents before. This particular concept has two parents, that one and that one. Very simplistic, and also the child. So here we can see that's the child. So a single child, it hasn't got descent. We don't list the descendants, only the direct child. So that's a very simple lookup on that concept. If I go back here, but if I want to get more information, so I talked about the attributes, then one thing you can do on the lookup operation is request the normal form. And the normal form is a way of explaining in an expression what is the representation of that concept. So if we run that particular one, again, I'll try again. So what we have here, the things we've seen before, the display, the designations, again, the descriptions, the properties, but also then we have another property now called normal form. Unfortunately, it doesn't fit out very well. But here we can see it's an investigation and a Doppler, and this is the expression that explains the procedure site is the gravid uterus structure. The method is ultrasound imaging. And so you describe it means that you need to be able to obviously interpret that expression. Yes, sorry.
Is it going up on the tree?
No, this is, so if you think of that picture, we had appendectomy, the parents and the attributes. This is explaining that picture, not further up the tree. So it's saying the direct parents and the attributes and how that concept is made up, basically.
Is there a list of those properties that you can query? Or how would I know to write this particular property in the string?
So expressions in SNOMED, which is what the normal form is, have a very particular syntax. And so by implementing that expression, being able to interpret the expressions, you would be able to actually interpret where those attributes sit.
I was asking in the query, use this particular word, not normal form.
Yeah.
Is there a list of those?
Yes, so if you go to the FHIR docs, it lists all those properties you can request. Obviously, not everything's implemented by every single terminology server. Yes, correct, yes, that's defined by FHIR. Yeah.
Like something like the search parameters on the resource.
Well, it's not search parameters, it's properties. So the code system controls properties.
Mm.
And what time.
Yeah. So I'll move on a bit because I'm talking too slowly. So here we go. So that's code system. We then have concept map, which is back to how do we find map targets? How do we map between SNOMED and, say, ICD 10 CM? So the way that we do this, here's an example. And running this through, again, you see now we have concept map is the resource and the operation is translate. The code that we're looking up is this one. And the system that we're going from is, we're SNOMED, we're in SNOMED CT is where the code comes from. The source is a SNOMED CT code, and the target is an ICD-10 code. So we want to find what is the ICD-10 code that's related to that particular SNOMED code. And this thing here in SNOMED saying this is the map record that it's part of. So if I click on this, it just gives me back. So for that code, the map target on ICD-10 is J45.9.
So essentially, you do this query on one terminology server,
Yep.
and that should have already implemented the mapping.
Yes.
So who does that? I mean, essentially, so you have SNOMED,
Yep.
there's ICD-10. Who takes on the task of doing this mapping?
So SNOMED International. So we already mapped to ICD-10. The NLM in the US mapped to ICD-10 CM. We mapped to ICPC, ICNP, a load of other ones, ICDO and so on. So we provide these maps, and those are released as part of the SNOMED editions. So when you load these into a terminology server, then you would get these maps in if the terminology server is importing those correctly. The thing that we don't do, at least with SNOMED International point of view, is we don't store the full other terminologies. We just store them as map targets. There are other terminology servers out there that store multiple terminologies, so you can actually get the information from other terminologies. So, okay. Another example is same as, so I talked about the history. How do we find out that a concept here, this particular one was inactivated? So this is no longer useful to me. I have this in my record. I've been told it's inactivated. But I can find out what has it been replaced by. And if I click this one through, it says, comes through and it shows me that it's been replaced by this newer concept. So again, from a machineable point of view, I can trace that traceability all the way through. Come back. Then we get into value sets. And I think this is really where you get into the power of FHIR and SNOMED together. The one operation that we really look into is expanding. So how do we expand what is in a value set? How do we find out what's in it? How do we query what's in a value set? And there are a number of parameters that are useful for SNOMED CT. If you look on the FHIR docs online, every terminology has slightly different parameters. So these ones are very specific to SNOMED. And I'll walk through these, what they mean. So the first one is just giving you all the concepts in that particular version on the terminology server. One then is I keep getting the word wrong, but essentially this is saying, give me the descendants, all the concepts that are a type of that. So if I say, go back, sorry. So if I had a code there for asthma, and I put the asthma code, then I will receive all the concepts that are a type of asthma. Reference set, this gives me a list of all the reference sets on the SNOMED terminology server. Then if I provide the identifier for a reference set, this will give me all the content of that reference set. A filter is another parameter which I can then add to. It's a term. I could put heart attack or asthma, and I'll do a search with that particular term. And then I can display the language. So I can choose to display Spanish or Swedish instead of English. So we have some examples on these. So it's a simple one. I want to get all the descendants of the code 276.24003. Now, if I click through, then you'll see now I start to get a long list of codes coming back. So this is, I've just limited to 10. We have a count on there, just allows us to limit how much comes back. But you can see this is a very simple, here's a list of all those concepts that are a descendant of that particular concept. if I go back. But then I can do the same thing in Spanish. So I add the display language in Spanish. You notice the other thing that changed here is the URL. And the URL now includes the module ID, which describes it as the Spanish edition. So every edition has a module ID, and this is the ID for the Spanish. So if I click through on this one, the same result comes back with Spanish descriptions. And we can do that for all the descriptions that exist. But again, the concept IDs are exactly the same, just a different display language. Then I could do something a bit more loose, like I want to find every description or every concept that has a description containing the words heart attack in. So here I've just gone for the FHIR underscore VS, so give me all the concepts, filter on heart attack, and just give me 10 back to start with. And here you see there are 9 of these apparently, and you can see that these, whilst you don't necessarily see that in the display, so if you look at this one here, myocardial infarction, there are synonyms that say heart attack on there. So this is where we come back to, we always display the FSN in these lists because it makes more sense from a clinical safety point of view. But if you go through and look at that particular concept, you will see that one of the synonyms is heart attack.
So the synonyms have different number rule. So I saw that they were like 9,000 or something, but real concepts have real.
Yes, so a concept can have multiple synonyms.
Yeah.
And so what we're saying is, so heart attack is not necessarily a clinical term. It's a localized term to how people describe myocardial infarction. So this just returns you back the concept and not the description.
I think I was asking if you can actually recognize by the number if it's a synonym or the real concept.
These are all concepts.
The synonyms have the different, they look different in the number. Oh, that was by accident.
No, they're all concepts.
Mm.
Synonym, hang on, concepts, they all are concepts.
Yeah. So the way of work is it's back to the unit of work, is always a concept. And so we move away from picking out the descriptions, it's always linked to that concept. So this is, that's what would go in the patient record, would be 2298006, because wherever they look at that record, it will mean the same clinical thing. And then finally, if I want to get all the concepts in a reference set, so this is a reference set for general practice. It's just got the ref set link label and then the ID. And this gives me back a list of, there are 4,289 concepts in this particular reference set, and here's just that list of what's in there.
Who is creating the reference sets?
Some reference sets are created by countries, by governments. Some are created by local regions in their own editions. As I said, reference sets are things that are published based on. So we have some internationally. Each country has their own ones. Sorry. Mm-hmm.
So, like the first URL, for example, why did you have to go to a value set to get the descendants of some, let's say, SNOMED CT code? But the descendants of that SNOMED CT code
Yep.
can be the same even if I directly query the server, right? Why did I need to query that within the context of the value set of FHIR?
That's how you do it within the context of FHIR. So everything that's back, it's a value set. It happens to be a value set defined with the SNOMED model. So what this means is I haven't had to go and manually create a value set with all those entries. I'm just using the SNOMED expression and model to get the information back. I'll move on because I think I've gone well over time, but I'll move on quite quickly. So we can also create a value set. This is very simplistically, it's an HTTP put with a JSON here you can see we have a resource type of value set, the URL for it, a timestamp, but also what's in it. And this one here is just an example of, we have a FHIR code and we have a SNOMED code. You can have multiple codes in manually created value sets. You can update that by just using a put with the same JSON. That will just update that value set. And also delete is just an HTTP delete request. Quickly going through, so that's a very simplistic thing, but going on to some of the advanced SNOMED retrieval where how do you find out attributes of a concept? How do you do the more powerful analysis? I'm just moving on quite quickly. So one of the things to show this is how SNOMED differentiates from ICD. So ICD-9 and ICD-10, I always like to think of it as very powerful for statisticians. And SNOMED is very powerful for clinicians because you have clinical meaning and another one which is used for mortality reporting, for example, which is where it started with the WHO. We mapped these classifications as I just showed, but the reason for just bringing this up is it shows you the difference of what you can do with SNOMED once you start to implement the advanced querying. So with ICD-10, if we were looking for viral pneumonia, we would say, does the patient have a respiratory disorder? And we would type in J, and we would get J12 back. But we wouldn't be able to know, does they have an infection? Does this disorder affect the lung? And is this caused by a virus? Because that information is not within the model of ICD quite correctly. That's not supposed to be there. With SNOMED, though, we know that viral pneumonia is a type of respiratory disorder. It's a type of infectious disease. It is a finding site on the lung structure, and the causative agent is virus. So it means that I can do a search across any of those particular attributes on that concept and always come back to the same concept. So we have some way to do that in SNOMED called ECL, which is expression constraint language, which means we can say, for example, here's a good example. The best one is, I would like to select a disorder or procedure using the location of where they occur in the body. So give me all the patients who have had a procedure on the airway structure. And I can find that by the concepts they've got in their patient records. We have a full syntax on that, and we'll talk about it in the next session. Where we see this getting used is things like data input. That's one of the key starting points, especially with type ahead. How do I make sure that I'm working in the same area? One of the issues I hear a lot is SNOMED's too big. How do we work with SNOMED? And sometimes that's down to, I see the implementation tends to be a big drop down with all the codes of SNOMED. Well, yeah, that's unwieldy for anybody. So you can use ECL as a constraint language to only display what's relevant in the context that you're working within. So if we were working in the cardiology department, you could restrict what they're querying based on this ECL, this query language. Here, for example, we can use it for type ahead for asthma. We're working in matching assessment scales, so I'm only ever going to query within the assessment scale hierarchy. So it just returns me back, and that's defined by this query syntax. What it looks like is these. I'll give you some examples. How do we find patients with any types of diabetes? We have a little two less than here that show, give me the patient's, any concept that is a type of diabetes. Then we say, how do we find patients with an infectious disorder of the lung? I want all the concepts that are, a type of infectious disease where the finding site is the lung. And so again, this comes down to a machinable query that you can use to find the information. So when your patient data is coded with this, you can do the analysis across the data to find that information. If I wanted to find any patients who had a behavior finding in the nursing health issues reference set, then here I can say, give me the concepts that are a member of that reference set and are a type of behavior finding. And it's a very simple, the query language is very powerful, and these are some simple examples, but you can see how you would provide reports based on patient-coded data using this. There's a load of syntax in here. I've talked about some of these, descendant of, or descendant or self of, parents of. You can do conjunction, disjunction, exclusion. So you can build up quite powerful queries to really produce analysis, but also to restrict what your users work with. And there's a full guide on SNOMED documentation that gives you a lot of information about this. I'd recommend having a look at that. Yes?
So what's the relationship of this language in use with FHIR? For example, if I have a comment.
Next slide. Yes, good question. So where this comes into is value sets. So value sets in SNOMED, there is a parameter which allows us to provide an ECL, so you can get that value set back with the results of that particular query. So an example here is we want to get all the concepts that are a type of chronic disease. The ECL is this less than sign in the concept, and then the FHIR looks like the same thing as before, but with ECL / the ID. They're always URL encoded, but that's the ID. So if I pass that in, we basically get the result of that query. So it's a very simplistic way. You can create these queries and just query them that way, and they come back as a value set through the FHIR Terminology Services API.
But if you're querying the patients, then you first do this, and then
Correct.
in your data, you have to query for it.
Exactly. So you pull back the information. If you're working in an analysis scenario, then, and generally you can do these on the fly, but you'll be saying, we want to find all the patients that have a type of diabetes, give me all the codes, and now find me all the patient records that have those codes. Yeah, it depends on the implementation, but Exactly. Go to Jim's talk tomorrow. The one thing quickly to get onto, because I know I've gone well over, is basically that you can create value sets as an ECL. So instead of having to always rewrite the ECL, you can put this in as a type of value set. So here I've created one that I'm going to call chronic disease value set, and the URL includes the ECL. So now I can actually just call that particular value set as chronic disease and expand it without having to always write the ECL. Yes, it stores, the value set is stored as that particular format there. So it just brings back the query. It depends on how some terminology servers might cache, some just run the query. So, and we can then expand it and we can filter on it. So here, using the filter parameter, I'm searching for heart on that. So if I did that, it looks like there, for example, everything in my particular value set that has heart. And it's essentially using that ECL query. And to close, just quickly, we have a session after this, a hands-on, where we'll go through these in a bit more detail. But this week, as Jim sitting back here has a great session tomorrow with more detail on how to use the Terminology Services API with a hands-on session. I'd strongly recommend going to that. Daniel Riemann from Loink will be showing how Loink works with FHIR. You know, all these terminology systems don't sit in isolation. They all need to work together. So I'd recommend going to see that. And then Rob Housen does a bit more advanced around terminology services, further steps on Wednesday. So I'd recommend, if you're interested in using the different terminologies, to go to those sessions. There's a load of information. I think these slides will be available, I believe, to everybody. There's a SNOMED on FHIR working group where we have quite a growing community between HL7, FHIR community, and SNOMED International. You're welcome to join that if you'd like to be part of that group. But have lots of links here. And in the next session, we'll be talking about how do we do this on our open source terminology server platform with FHIR Terminology Services. So there we go. And if you have any questions, come up afterwards, or please stay for the next session. Thank you.